Alright, here we go. Back with another chapter of Natural Wonders. Today we're looking at metamorphic rocks with Natural Wonders chapter 6. So make sure you have your Natural Wonders packet out in front of you, and here we go. Start off Natural Wonders chapter 6. There are a couple really important paragraphs with some information we need to talk about. So underline and highlight some important things as we go through it. This chapter is all about metamorphic rocks, and that word metamorphic, metamorphism, just means to change. And the way rocks do that is through heat and pressure. Those are two key variables that cause changes within rocks. And metamorphism, to change, is something you've heard since you were little. Probably in elementary school when you watched that cute little caterpillar turn into a butterfly. That's a metamorphism, a change. So we're taking any of the previous rocks, sedimentary, igneous, or a metamorphic rock, and we're putting it under heat and pressure, and that causes a change. When we talk about the two categories of metamorphic rocks, it's either going to be foliated or non-foliated metamorphic rocks. And foliation is really just color banding or layering that happens in a metamorphic rock. Non-foliated means there's no color banding, no layering, and we're going to see examples of both. When it comes to the three different types of metamorphism, the most widespread type of metamorphic rock is a regional metamorphic rock. And this occurs through mountain building events. Like right now, currently the Himalayas are experiencing a mountain building event where India is colliding with Asia, and the continental crust is getting squished together, it's getting crunched, and there's a lot of pressure that leads to a lot of heat, and so we have lots of changes to rocks happening. Another type of metamorphism is contact metamorphism. And this happens when a rock is in direct contact with lava or magma. It's almost like a burning that happens. Really high amounts of heat, but very low pressure at times. And the very last type of metamorphism is burial. We don't see a lot of examples of burial metamorphism, but this would occur when sedimentary rocks are deposited on top of rock layers. So you're just adding more and more and more sediment on top, so there's a lot of pressure on the rock layers deep below. As we get into looking at each and every rock, it's going to be really important this week to remember the process and also the parent. Okay, the parent rock of each of these metamorphic rocks is what type of rock it was before it transitioned and metamorphosed into what it is now. So you do have to know the parent rock and the process. If we look at the very first rock, we're looking at gneiss. And gneiss is a high-grade regional metamorphic rock. And the high grade just means how much change has really happened to that rock. And as you see the video play through, you're going to see very distinct layering, very distinct color banding taking place. And that means there was a lot of heat and a lot of pressure. The pressure flattens minerals and kind of like Play-Doh, flattens them and stretches them out, elongates them. And the heat allows those minerals that are now flattened and elongated to kind of move through this semi-solid rock and join together, band together to make these sometimes very thick color bands. The parent rock here would be either granite or shale. You're going to see that as a common theme among the parents, is that a lot of these rocks can start as shale. Moving to our second rock, we're looking at schist. And schist is a medium high-grade regional metamorphic rock. That's the process. I know it might look a little different in your packet, so scratch that out and write these words down. Medium high-grade regional metamorphic rock, with a parent of either shale or a lower metamorphic rock phyllite. And what would be key to look for in schist is the layering. We don't have color banding anymore like we had with gneiss, but we still have foliation, which color banding is foliation, layering is foliation. We still have foliation taking place with schist. So as this rock rotates, you can see several areas where you can see some very distinct layering. The next rock is phyllite, and phyllite is a medium low-grade regional metamorphic rock. Again, might say something different in your packet, so use your pencil, scratch it out, write down medium low-grade regional metamorphic rock for phyllite. And this is even a lower grade, meaning even less heat and pressure which means the layering is getting more and more fine and hard to see. As these samples of phyllite rotate, you can still see some pretty distinct layerings with parts of the rock, different angles, but it's definitely not color banding like gneiss, and the layers definitely aren't as distinct as schist. Phyllite's parent rock is either shale, which is our common parent, or slate, a lower grade metamorphic rock. Our fourth rock and the last foliated metamorphic rock we're going to see is slate. Slate is a low grade regional metamorphism, and it has a parent of shale. And with slate, it is pretty hard to see the layering taking place here, the foliation. But as this rock rotates around, there are angles where you can definitely see some very thin, fine layers. And it's important to recognize those. Moving on to the back side of your packet, we have our non-foliated metamorphic rocks. And the first one we're going to look at is quartzite. Quartzite's parent is sandstone, and this makes sense because most sandstone obviously is made out of sand, and most sand is made out of the mineral quartz. So that's why we name this rock quartzite. And what has happened to those sand grains under heat and pressure is the sand grains have just become kind of soft and mushy. So due to the pressure and the soft sand grains, the sand grains kind of mold together, they kind of interlock, and that forms quartzite. It has a range from either medium to high grade regional metamorphism, or it could also be a contact metamorphic rock. Our last sample is marble. This is another non-foliated metamorphic rock. The parent here is limestone. Marble is often a contact metamorphic rock that forms when limestone is in contact with magma or lava. That's going to wrap up Natural Wonders Chapter 6. Please make sure if you have any questions you ask, otherwise I'll see you in class. Thanks.